during a certain week, the mean price of gasoline was $2.70 per gallon. You're going to take a random sample of 36 gas stations from the population. What is the probability that the mean price for the sample was between $2.60 and $2.80? They give a standard deviation of 0.04 for the population. So let's just draw the original distribution and then our sampling distribution just for our information here. The original distribution is a relatively wider bell curve than the sampling distribution. The sampling distribution is always narrower because anytime you take a sample that's bigger than an N of 1, see, N of 1 is the widest spread that you can get for your distribution. If you do an N of 2, then what you're going to get is something that's a little bit narrower, like this. That might be an N of 2. But if you go with 36 gas stations and average all those results, we're talking about a very narrow curve. So the bigger the N, the more narrowed it becomes. And the reason why is because you're averaging members of the population where some of them are big and some of them are small, and their differences will cancel out. What's going to happen is the standard deviation of the curve will always be sigma over square root of n. So the bigger the n, the smaller the standard deviation becomes, and we'll end up with this eventually. Now let's see, the mean price was $2.70. One standard deviation above would be $2.74. Two standard deviations above would be $2.78. And then we'll have over here $2.66 and $2.62. The boundaries that they're describing are $2.60 and $2.80 though. So that would be like over here and over here. They want to know the chance of the station having a price between those extremes. Now, if they just wanted to know the chance of one station being between $2.60 and $2.80, we could find that using the techniques of the previous investigations that we did. And I'll do that just for comparison. The old versus the new. Okay, so if we want to know the chance of any given station being between 260 and 280, we got to find this area. Now we could do that with, let's say, the online StatBook app. What you do is say that you'd put in your mean of 270 and your standard deviation of 4 cents, and then just say that you want to be between 260 and 280. It's almost all the curve. Almost all the stations will be between those values. 98.76% of the time, the station will be between those values. So that's for one station. Now they're asking, what's the chance of getting a sample of size 36, averaging all those stations, and having that be between 260 and 280. So to answer that question, what we've got to do is we could follow the procedure of X to Z to P. That'd be one way to do it. So we could say, okay, we're going to turn this into a Z, But we have to use the formula now of z equals x bar minus mu over sigma over square root of n, because we're taking into account that this has a different standard deviation than this one had. This one would be just z equals x minus mu over standard deviation. So if you do this for the left side and the right side, what you'll get is you'll get 260 minus 270 over 0.04. So that's just negative 2.5. And then if you do it for the right side, you'll get positive 2.5. So now we know that the z-scores would be negative 2.5 and 2.5. Apparently that corresponds to 98.7% of the area. But the z-scores down here are not going to be negative 2.5 and 2.5. They're going to be different because we have to use this formula. So 260 minus 270 over 0.04 over a square root of 36. Do that on calculator, I get negative 15. And then do it for the right side as well. And I get 15. Keep in mind that those are z-scores. 15 standard deviations below the mean and 15 standard deviations above the mean is what we're talking about. So you could go back to the app, the stat book, but you got to plug in a new standard deviation for your curve. It used to be 4 cents. Now the standard deviation of the sampling distribution is 0.67 cents. So plug that into the program, right? And now we can see that the area is approximately everything. It's so close to 1 that the computer is not even going to distinguish the value from 1. Keep in mind that if we wanted to draw this same picture without the mean and standard deviation, just do 0 and 1, and then tell it you want to be 15 standard deviations below the mean and 15 standard deviations above the mean. How much area is that? It's the whole thing. It's the whole thing. I mean, if you were to do the negative 2.5 and 2.5, okay, that's 98%. But we are talking about negative 15 now and 15. So the answer is that the probability is about 1.